Hello, everyone. A very good afternoon to all. Dear authors, invited guests, welcome to the technical session 1A. My name is Anisha and I am the moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 7th International Conference on Information and Communication Technology for Competitive Strategies, Chandigarh, India through Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. In these sessions, we have 8 presentations and each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answers. And on 7 minutes, I will raise a gentle reminder. Also, there is a request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, then you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of the session, Professor Gitanjali R. Shinde. Dr. Gitanjali R. Shinde has overall 15 years of teaching experience, presently working associate professor in the Department of Computer Engineering, Vishwakarma Institute of Technology, Pune, India. She has done PhD in wireless communication from CMI Aalborg University, Copenhagen, Denmark. She has presented a research article in World Wireless Research Forum meeting, Beijing, China. She has published 50 plus papers in national and international conferences and journals. She is author and editor of 10 plus books. Her book, Data Analytics for Pandemics, a COVID-19 case study, is awarded Outstanding Book of the Year. Professor Gitanjali R. Shinde, welcome to the session, ma'am.
Thank you, Anisha, for a nice introduction. Good afternoon to all authors.
Okay, so now we will start with the papers. And our first presenter is Anil Rawal, and the paper title is A Survey on Deep Learning Methods for Addressing COVID-19 Issues. Dear presenter, you may please start your presentation.
Yes, ma'am. Is my screen visible?
Yes, it's visible. Please go ahead.
Good afternoon. Myself, Anil Rawal, and I will be presenting on deep learning methods for addressing COVID-19 issues. So background of the study is inspired by the fact that some commonly used tests like RT-PCR antigen and antibody, which are crucial for identification and tracking of cases of infection, have some major drawbacks like long turnaround time, false negatives, and many a times not effective in detection of an active infection. In addition, other obstacles can be limited number of kits, more time consumption, and interruption of process due to several physical and demographic parameters. In addition, to fight any epidemic, not only diagnosis and detection of infection, but drug development, constant monitoring, contact tracking, differentiating from other disease, breaking chains of rumors, that is fake news detection, and predicting outbreak too holds equal importance. So for diagnosis of coronavirus and speeding up the related process, there was a need of searching some alternative methodologies that can serve for more accurate and more sensitive detection of COVID-19 virus. And this was the main reason why DL models were used in radiographic techniques. So here we have analyzed DL application for COVID, including the diagnosis, treatment, and for other data. So this only was the main motivation for analyzing this topic, that DL can not only be used for diagnosis and detection, but also for contact tracking, detection of fake news and outbreak, and to learn nature and characteristics of infection transmission. By simplifying and rationalizing task of analysis of genetics and protein structures, deep learning can help in estimation of various organic combinations, which can help in state-of-art predictions of drug and vaccine synthesis. Survey with CT images shows the use of various DL models for the task of identifying and localizing pathological patterns from the videos, identifying COVID and non-COVID images, that is infection prediction or COVID diagnosis, and for inverse graphics. Survey for chest X-ray shows the deployment of various models like VGG 16, 19, Inception, V3, ResNet 18, 34, 50, SqueezeNet, DenseNet, and especially DarkNet with YOLO architecture. Now, as a part of sound analysis, N-based device with microphone array, thermal camera, and neural computing engine was best at identifying flu-like disease by analyzing the breathing and collecting the cough data. For differentiating COVID from other diseases, deployment of existing models were seen along with some advanced versions of Exception MobileNet, ResNet 101, NASNet, and Inception V3. Finally, for other data like prediction of outbreak, identifying best treatment, and fake news detection, application of traditional models and genetic algorithm along with some advanced attention mechanisms and reinforcement learning have been seen. Here we have analyzed different models of DL dealing with and tackling COVID issues, but this analysis and application of models are not only limited to COVID, but are also applicable for any respiratory infection diagnosis and epidemic prediction. Challenges that we have identified included inadequacy and restriction of data set, time consumption while dealing with training data, secure data collection, and tackling of unbalanced data sets for medical imaging. In addition, online data has some cons like misdelivery, privacy, security, finding the relevant data from pool, and tackling of noisy as well as missing data. Furthermore, for easy manipulation and to guarantee availability, data must be transferred to cloud. And when role of cloud comes in, privacy and security issues, 2 steps in like whistleblowers, collection of patients' attributes, storage, tackling, and proper retrieval of data, ensuring consistency and validity up to date. Future directions include handling of all above mentioned challenges along with the deployment of automatic classification for CT scan, X-ray, and for breaking the chain of transmission. While considering the drug development, future vaccine structures for mutation can be analyzed and developed, identifying the behavior of composition along with its reaction on humans. So finally, DL can solve the decision of selection of appropriate data and equipment along with tackling the heterogeneities in data. Concluding this survey, this deep learning can assist in voluminous data analysis optimization, and it can set and train machines more accurately and efficiently to handle this COVID issues. So this can pave new directions towards the development of completely automated decision support system for medical experts regarding research in diagnosis.
Nice presentation. Can you go to the slides where you have presented tabular format literature survey?
Yes, ma'am.
Okay, so again, previous slide. Okay, so you have done literature survey for almost I think 30-40 research work. So may I know exactly how much accuracy they achieved and exactly which data set they have used?
Okay. for this task of differentiating disease, here okay, for this task of chest X-ray, for example, here darknet with YOLO architecture seemed to be most real time with the accuracy of 98%. And generally, all the models, all the papers have used different data, but their attributes are nearly same, nearly comparable.
Okay. Can you give some findings? Like one finding you have already given the challenges. What are the other findings you understood from this survey?
Yes, ma'am. One main challenge for this purpose is that this field requires DL knowledge as well as medical expertise, both.
Okay, so it was nice presentation. That's it from my side. Audience, do you have any questions? Okay.
Thank you so much for the great presentation. And now we will move further to our next presenter. And I would like to invite our next presenter, Bhuvneshwar Tendulkar, to present his paper on the title Analysis of Prediction Performance of Machine Learning Techniques on Diabetes Dataset. Dear presenter, you may please start your presentation.
My screen is visible?
Yes, it's visible. Please go ahead.
Yeah, my topic is the analysis prediction performance of the machine learning technique on diabetes detection. And my co-partners and my helpers are Dr. Chandrani Singh ma'am and Dr. Ankush. Okay, let's go with the abstract. Currently, if we see diabetes are almost there. If we see in our daily life, our one familiar man or one relative, it starts suffering from the diabetes. As per, if we see the WHO report, the WHO says the currently 400 to 20 million people are affecting using diabetes detection. Then diabetes federation also say in the 2024 almost 684 people can be suffer from the diabetes. If we see in our health life or the health issues are just because of the diabetes. If you want to do any operations, then they will first check the diabetes is the normal or not. Sometimes the operations was cancelled just because the diabetes is high or low, and it's just because of the age, obesity, or the we are not doing exercises daily. That's why the diabetes can be good. If we see 1 minute. The diabetes recently affected around 346 million people. It's the research of the WHO. Then they have also major causes of the heart stroke, kidney failure, lower limb amputation, and blindness, and more. Some key facts are justifying to conducting the said research. If we see, we have the lots of data of the health industry about the diabetes and everything. We can easily calculate data from the health industry. Then we can use, then we see the hidden patterns because of like BMI, obesity. Then we can easily find the diabetes detection. Then we use the 5 machine learning algorithm for to the finding diabetes detection or not. The okay, we go through next slide. The data collection, data set collection. We are find the PMI diabetes data set. They are the 2,000 patients. 1314 is the non-diabetic patients, and 684 patients are from the diabetic. The attributes are for in that data set, the pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and age. BMI can calculated by the age, then height, and the weight. Okay. Then we pre-process on our data set. Our data set is 2000 of data. Then we first analyze data, how much data we have. Then we count how many data is non-diabetic. Then what is the median mean. Then we remove the missing values from the data set. Then we cancel all the noisy data. Then we data standardization to the 0.1 format. Then we use the train test plate for that data. We train test split is the 80-20 ratio. Then we train our model and apply all 5 algorithms. We can see the next slide. The machine learning algorithm we use for that diabetes detection. First is the support vector machine. Second is the k-nearest snack board, random forest classifier, Gaussian naive Bayes, and gradient boosting classifier. Support vector machine. Support vector machine is the classifier we can use for the classification data set. Then we are use one hyperplane using this algorithm, SVM algorithm. Then we find the one is an outcome of the blood pressure, blood glucose level. Then we find to the outcome, we can say the blood glucose level also are it's depend for the diabetes. Then we go through the next slide about k-nearest board. This is also same algorithm for the classifier, classification algorithm. Then we use for the error rate ratio for that our data set. Then we find the error rate. Then we use the random forest classifier. Random forest classifier is like this. The backend work means they are dependent like the graphs, and they are take using decision on the graphs. Then we find 1 minute. Then we apply this functionality on our data set. Then we created one new BMI column for that table. The BMI also mandatory. We can recognize using BMI diabetes because BMI is the greater than 18 or lower than 18 or less than 25. We enter some data is obese, overweight, and this type of data. Then we find data set. If the overweight is done, then they definitely have diabetes. If we see obese and overweight are diabetic patients. Then we go through the Gaussian naive Bayes. We apply this algorithm also on our data set. Then we find true positive sensitivity and false positive specification. Then we use the result. Okay, we go to the result. This is our best algorithm out of 5, the random forest algorithm. We apply random forest algorithm, our train model. Then we predict X test. Then we created accuracy score. The accuracy score will be 97 and ROC score will be 97%. If we see comparison out of the almost the 5 algorithm, the random forest will be best algorithm, and second best algorithm is the gradient boosting classifier. The random forest classifier score 97%. 97%, and the gradient boosting is the 18 and 87%. That's all. We use. Any questions?
Okay, it was nice presentation. I would like to know that how many features were there in your data set?
1 minute. We go to the first slide.
Okay, so yes, 8 features. So have you used all these 8 features for the analysis or building the model, or have you checked any correlation and then only selected the few features for your analysis or training the model?
First, we check the correlation also. The insulin and BMI is the mostly correlated to that data set. Then we check the everything like skin thickness also important or not, blood pressure also are important or not. That's why we use all 8 attributes for our data set.
Okay, you have used the random forest and gradient boosting also. Can you
Yeah.
tell me how exactly these two algorithms differ with each other? Because one is of the bagging and one is of the boosting. So can you explain in your case how both these two algorithms have worked?
Which one? Random forest and
The gradient boosting algorithm.
okay. Random forest algorithm is the decision forest algorithm, man. Then it's totally depend if the age like they in the backend we see they are the creating the one graph and exact like tree and graph. Then we can take the decision on the random forest, and it is the best score. That's why we not go the gradient boosting algorithm.
Okay, in random forest, how many decision trees have created?
Uh, I have to see.
Okay,
I'm
is
not
there,
in.
okay, fine. Is there any facility by that way we can control number of the decision trees that should be created on your data set?
Can you repeat, ma'am?
That is there any facility to control number of decision trees? That is how many number of decision trees you want in your random forest? Is there any facility there?
Yes, ma'am.
Okay. Okay, fine. Audience, any question from your side? Okay, so I think we can go for the next presentation.
Okay, ma'am.
Okay, so thank you for your great presentation. And now we will move further to our next presenter. And I would like to invite Pavita N to present her paper on the title Comparative Analysis of Classification Models in Design Process of Ensemble Classifier. Dear presenter, you may please start the presentation.
Yes. I hope my screen is visible to you.
Yes, it's visible.
So my paper title is Comparative Analysis of Classification Models in Design Process of Ensemble Classifier. So that means we are developing an ensemble classifier, and before developing an ensemble classifier, we have analyzed different classification algorithms before developing the ensemble classifier, that is stacking based ensemble classifier we are developing. And the agenda for today's presentation is we'll start with introduction, then methodology, then results, conclusion, and the references. As an introduction, I just want to give the application domain where which we are applying this particular model. So this model is applied to the financial domain, particularly for the credit risk management or the credit risk prediction. So this credit risk prediction has become very challenging job in case of financial sector, mainly for the banks and the financial organizations. And various researchers have attempted many machine learning algorithms for predicting credit risk associated with the bank lending. And the purpose of our research is to compare different machine learning algorithms on two different practical data sets from Indian Bank and the NBFC. So let me give a brief overview of the data set which we have used also. The data which we have used is collected primarily from, one is from a private bank and the other one is from an NBFC. So both are primary data. So it is regular customers transaction data. So both the data sets are having more than 1 lakh records in the data set. And many features were also there. And the features were first, what we have done is we have collected raw data from this private bank as well as NBFC. So after collecting the private data, data from the banks, so then we have gone through the literature and we have identified the various features which are actually necessary for an classification model, in particular the credit risk prediction model. So after identifying the necessary features, we have selected only those features from the primary data, and then we have collected the features with more than 1 lakh of records. So after identifying the features which are necessary for credit risk prediction, then we have already also done some pre-processing techniques as well. So our methodology goes like this. First, we have collected the data, and then on that collected data, we have applied some pre-processing techniques. And then after that, we have separated out training data as well as testing data. And in the training data, again, we have done the cross-fold validation, that is 10-fold cross-validation. And then on that 10-fold cross-validation, we have applied different machine learning algorithms. And from the 10-fold cross-validation, we have then calculated the average accuracy, which is the best performing accuracy. And then that accuracy we have tabulated. And from that, we have selected the best models for our purpose. At the same time, on the testing data, we have validated our model. So it is like a two-way validation. Once we have done with the cross-validation, that is 10-fold cross-validation we have done. Then on the final testing data, we have tested our results. And then after selecting the best model, then we have created the ensemble model. So in this paper, we are not going to discuss about the ensemble models, but we are going to discuss about the different classification models which we have selected before the creation of ensemble model. And the models we have analyzed are, first one is the logistic regression model, and the second one is the extra tree classifier, then random forest classifier, and also XGB classifier, then LGBM classifier, then neural network, and then support vector machine, ridge classifier, k-nearest neighbor classifier, then linear discriminant analysis, and the quadratic discriminant analysis. And these algorithms we have applied on two data sets as I said. This data set one, which is a data set from a private bank, whereas this data set two, it is a data set from the NBFC. Okay, so on the logistic regression, on the data set one, we got an accuracy of 0.94168. And on data set two, we got an accuracy of 0.9893806. And extra tree classifier has given an accuracy of 0.94128 on data set one and 0.93903 on the data set two. And random forest classifier has given an accuracy of 0.94184 on data set one and 0.93988 on the data set two. And XGB classifier has given 0.95421 on data set one and 0.95671 on data set two. Then LGBM classifier has given an accuracy of 0.95426 on data set one and 0.96327 on data set two. Neural network has given accuracy of 0.94138 and then accuracy of 0.93903 on data set two. Then support vector machine has given 0.84148 accuracy on data set one and 0.83506 accuracy on data set two. Then ridge classifier has given accuracy of 0.84026 and accuracy of 0.83804 on data set two. And k-nearest neighbor has given a classification accuracy of 0.83194 on data set one. And on data set two, it has given an accuracy of 0.83898. And then we have used a linear discriminant analysis, which has given 0.8452 on data set one and 0.86571 on data set two. And then quadratic discriminant analysis has given accuracy of 0.86436 on data set one and 0.85346 on data set two. So these are the different algorithms which we have analyzed on both the data which are primary data. And as a conclusion, in the modern world, predicting loan default is a significant and a difficult task. So in this study, we have investigated and examined machine learning methods to determine whether or not to borrower is in a default for a particular loan or not. And the different ML models, namely logistic regression, extra tree classifier, random forest classifier, XGB classifier, LGBM classifier, neural network, support vector machine, ridge classifier, k-nearest neighbor classifier, linear discriminant, quadratic discriminant are analyzed on 2 different data sets from the Indian market. And the experimental result shows that LGBM is the best ML model for both the data sets with predictive accuracy of 0.95426 on dataset 1 and 0.96327 on dataset 2. And top performing models are selected as base classifier for our future ensemble model. And in the future work, a novel ensemble classifier is designed and it is implemented using best performing ML algorithms.
It was nice presentation, Pavita ma'am.
Thank you.
So I would just would like to know what are the different data preparation methods you need to do it on your data sets?
Actually, a lot of data pre-processing we have done on this data set because it is completely a raw data when we collect from the MIS of the bank or from the MIS of the NBFC. So initially raw data is collected. So then after going through the literature and also after concerning with the bank personnel, so those who are working on the credit risk domain. So we have identified which features are relevant for our application. So then we have collected those features from the MIS of those banks and the NBFC. So after collecting those features, we have applied many techniques, like they had numerous null values were there. So those null values will be replaced by the median value. Then also some missing values will be there. So missing values data we have neglected actually. And then the null values will be replaced by the median values. Then also we have checked for the correlation also. Some features had correlation with very high correlation. So those features we have dropped again. So the features with less than 0.75 correlation only we have considered for our study. So likewise, many techniques we have applied.
Okay, ma'am. And whether it is balanced data or imbalanced data set?
It is an unbalanced data set.
Okay, so is there any technique you have applied for that?
As of now, we have not applied, but the reason for going for ensemble technique is the same because of an unbalanced data set. When we use a single classifier, you can see the accuracy is not very high. So when we go for the ensemble techniques, it will increase the accuracy because of the unbalanced nature of that data set.
Okay, one of the last question, like in which applications we should go for the stacking instead of bagging and boosting?
In case of stacking, what happens is we can choose different algorithms. So there is a chance for applying in many levels. So in our case, we are planning to apply for the multi-stage stacking classifier. So output of one stage is given as input to the next stage. So stage-wise, the increase in accuracy will be there. And similarly, the multiple algorithms we can duplicate in different stages as well. So whatever the top performing algorithms we can repeat in different stages. So that is one of the advantages of stacking.
Nice presentation, ma'am.
Thank you.
So that's it from my side. Audience, do you have any questions? Okay, so I think we can go for the next presentation.
Thank you for the great presentation. And now we will move further to our next presenter. And I would like to invite Venkata Vivek Gauripeddi to present the paper titled Digital Twin for Smart Factory Network QoS Enhancement Experiments. Dear presenter, you can start the presentation.
All right, surely. Thank you. Just let me know once my screen is visible.
Okay, it's visible now.
All right, great. Yeah, thank you. So good afternoon, everybody. I'm Vivek. I'm a part-time master's by research student at Network and Communication Lab at IIT Bangalore. And otherwise, in my day job, I work to provide solutions to a lot of automotive and manufacturing customers for networking related activities. So to just give a context of this work, this is where I come from. So we work pretty much on the manufacturing shop floor. This is a two-wheeler assembly line you can see, and these are spread out over 2 kilometers in length and around 1.5 kilometers in width. So that's how huge the plants are. And for Industry 4.0 or for digital transformation of this factories, so network is the backbone of it, because we like to connect all the machines on the shop floor. You have different CNC machines, robots, and other systems. So we connect all of that and get all of that data and pump it to the northbound, which is the ERP or the cloud or the plant level IT layer. So for this, network becomes a really, really key thing. And the designing of the network, maintenance of the network are key important functions of networking managers in these companies. So here, let me just talk a bit about digital twin and why it is needed in shop floors like this. So in simple terms, digital twin is just a virtual representation of any physical asset. And then all the different processes, data that happen on the real model are integrated on the virtual model. So you can just fast forward in time as to what happens in the network, get the results, and help design the product better and better over multiple iterations. So that is what digital twin essentially is, and why digital twin of smart factory is needed is that we cannot conduct any experiments or know the performance of a network by disturbing the operations that are happening, because you know how the two-wheeler market or four-wheeler market in India is. It's just growing rampantly. So there is no way you can stop the whole factory to kind of do your experiment. So that is the reason we bring out a complete digital or virtual model of the factory. And then there we conduct different experiments as to how to improve the bandwidth, how to improve the throughput, how to reduce the latency, and other experiments, as well as the maintenance of the network. So we know what the load on the network is and how we can better add networking infrastructure like routers and switches to make it better. Let me talk about the core of this paper, which is on the digital twin framework of a smart factory network. So on the left, you can see how the factory shop floor is. I've already explained what are the assets. We have different CNCs, sensor gateways, and others. And then these are linked to an edge. And then from edge all the way, they go to the main server. So we have these three different links that are there in the whole network. And then so we try to replicate all of these links. And this is just a simplified model. So in a real model, we have multiple machines across multiple lines, multiple switches. So it's just into N. So just taking one part of that and emulating that into a digital twin model, you can see all of these objects are created logically in a software called NetSim, which I'm going to talk about in the next coming slides. And then what we are doing is to bring and understand the real-time data, right? So we are getting the actual factory data, because normally what happens in factories, we have two kinds of data. So we have a cyclic data, so which comes on a regular intervals, and we have some acyclic data, so which comes as and when needed. So these can be your things like alarms and others from the machines, or maybe some kind of an emergency that comes through. So all of that is acyclic, and the regular operational data is cyclic. So we have these two different kinds of data. So what we did for this work is get the actual data which is stored and then retransmit it through the network. So we understand what is the performance of the network in with actual load and actual kind of data that is used. So here is just a sample representation of data. So I think on the top, you can see there's so many columns. There is a lot of things related to the plant that are there. And then this is just a small visualization of the data. And then it has alarms data and other data as well. So this real-time data, we took it through the network. And this we connected to another software called NetSim, where here you can see this, the screenshot shows the complete, all the machines and others in a virtual environment. And this is the switch, and I can have the router, and this is the edge or the server. So we studied at this links, what is the performance of the network. And then through our own software or scripting, we've converted the old data to live streaming data and sent it to these machines. And then the flow of the network is maintained. So in that way, it's a complete digital twin where you can see with actual data what the performance of the network is. So yeah. Just a sec, yeah. So yeah, coming to that, so this is some of the results that we have observed. So as you can see in my previous slide, we have different links here from the main switch to the router and from the router to the main server. So this we call it as LL5 and LL, logical link 5 and logical link 6. So we studied this digital twin network, changing that network to different link speeds. So we had 100 Mbps Ethernet line in one experiment. We had 100 Mbps and a gigabit per second Ethernet line, and both gigabit per second Ethernet line. And we can see the performance, how it improves. So we can see a reduction in 23% in latency when we change one of the links to a faster link. And we can see almost 47% improvement when we change it to a much faster link. And this we've done it for different machines and increasing the load on the network, dynamic loads. So similarly for jitter, we've done the same experiments. I can see a drastic decrease in the jitter when we increase the links in the network. So all of these experiments to do and check what the performance would be on a real factory would be near to impossible. So by building a digital twin framework like this, we can have these network enhancement quality service experiments, so with which we can determine what can be improved and where it can be improved and what the expected results can be. And we've also done theoretical calculations, so just to see that our digital model is not off. And you can see that in throughput, it's almost there's a 5% difference in what the theoretical and this one is. And in the latency, we can see a big gap because in calculations, we normally ignore the processing time and others, but then whereas in the network simulators, all that is undertaken. So all of these are accurately calculated, and digital twin brings some comprehensive analysis of the network rather than just theoretical calculations. And further work would be to have cybersecurity models implemented and network scaling models be implemented. So ideally, with the real data and the virtual network, anybody can design a network and measure the QoS parameters and other key network information on this particular framework. So yeah, so thank you for your time, and yeah, feel free to ask your questions.
It was a great presentation about the digital twin. I would just like to know that how we can set the initial parameters in digital twin, like as you have shown for the factory. So what are the different ways that we can set the parameters?
Right, ma'am. So primarily one thing is, so when we start with, right, so on the edge side is to have a base rate. So what we normally have is when one machine is running, we know what the data rate for that machine is going to be. So from that we start, and then that we multiply by number of machines that are there. And also in the software called NetSim, so there are a lot of already is also pre-built software by one of the largest companies. So they also give a lot of options for us to tweak in the network, set the bit rate, set the error rate, control packets, and the router configuration. So exactly which router you have on the floor, the same router settings, you can set it in your software. So this helps in making it more real or more closer to the actual conditions.
Okay. And like in our real scenario, we are having lot many noise or some parameters that definitely cannot be there in simulation. So what are the effects in your the results of digital twin?
Right. So here I've mentioned, so in that effect, so some of the things that we miss are processing delays and other delays. So I think by having this experiment run, maybe we can develop an additional model as an error correcting model that can sit on top of the digital twin, where, like some of the other papers have discussed on machine learning. So we can feed the real data and the digital twin data and further try to improvise. So basically there are 5 levels in digital twin. Level 1 to 5. So level 5 is the cognitive twin, which means that it corrects itself and evolves over time. So what we've done is the level 3 twin, where it is just a prescriptive model to say that if this happens, this is going to happen. So as and when we have more and more data, we can apply more ML models to improve and take it to level 4 and level 5.
It was nice presentation. That's it from my side. Audience, any questions? Okay.
Okay, thank you for the presentation.
Thank you.
And now we will move further to our next paper. And I would like to invite our next presenter, Nalini S. Jagtap, to present her paper on the title, Improvised Image Fusion System Using Amalgamation of Histogram equalization with PCA. Okay, so she has started the presentation.
Yeah, good afternoon all. I hope I am audible and my screen is also visible to everyone.
Yes, it's visible.
Yeah, good afternoon. I, Nalini Jagtap, I'm presenting a topic as an improvised image fusion system using amalgamation of histogram equalization with PCA guided filter and CNN hybrid systems with co-author as a Dr. Sudeep Thepde. With reference to this, actually, first I will like to give a background of this topic. Today's era is full of cameras and photos. And with advancement in vision technologies and storage media, we have scope of improving the clicking scenes and techniques too much. The camera is having the optical device. Camera is one of the optical device which captures the scene or an object with an electronic sensor. Now, with variations in a focal length, then camera subject, distance, depth of the field, we are probable to get the images with a different focuses. Even even with due to the climatic atmospheric reason or due to the illumination variations, we get sometimes the ill effect illuminated images also. So here we have multiple images. A world is full of images, but nothing is of a good quality because of the constraints of the clicking devices. And now we need one technique where we can fuse all these illuminated images or the differently focused images to get one single image with all the content, with a good quality, good contrast, and a equal focused image. So this is what is the background behind the study. And let's move towards the agenda or the flow of this presentation. So here I simply give the introduction about the topic, then the methodology, experimental analysis, and the contribution of this particular proposed methodology in the domain of this image fusion. So let us move ahead and see what is the image fusion. Now, image fusion is a process which is a process of collecting of all important information from multiple images and combining them to result in a single image. Now, this single output image is more informative and accurate than the single source images or the set of the source images. The purpose of this image fusion is not to reduce the amount of a data, but also to construct the images that are more appropriate, understandable, and human readable, human as well as the machine readable as well. The few of the application areas for the image fusion can be listed as military area, then clinical or the medical domain. Then we have the crime prevention, such as the surveillance applications, then web browsing and remote sensing. Now, in the image, we can see that these are the two input images. Say the one image is with the left focus, another image with the right focus. And after the fusion, what we will get is all-in-one focused fused image, where this right focus and left focus image is fused together, and we get a single image where we have the focus on a complete image, not to one particular area. We have multiple requirements in this image fusion, like the reduction in the storage, or we have the characteristics like the information conservancy. Then we have the reliability is one of the characteristics, and the robustness from the fused image. Let us move towards the little about the background of this particular literature, or what has the state of art, what has happened till now in this area of the image fusion. So these image fusion techniques are broadly divided into three parts. These three parts are the special domain image fusion techniques, transform domain image fusion techniques, and learning domain image fusion techniques. This special domain is generally work with the location of the pixels, and it consists of the pixel based, region based, and the optimization based images. When we move to the transform domain image fusion techniques, we have multiple transforms like the discrete cosine, discrete wavelet transforms, as well as we have the scaling algorithms like the gradient based scaling, or we have the pyramid based algorithms, or we have some sparse representation techniques. So these all techniques comes under the transform domain techniques. And then we move to the learning domain techniques. Now, in this learning domain techniques, especially when we have a reference or we know the classes or the class labels in hand or beforehand, then it get divided into supervised. And if you don't have the references or the class labels, it is unsupervised. It means that if you don't have the reference images or the ground truth is not there with us, we have to follow the unsupervised techniques. Now, what we have seen from all these division of the image fusion technique is generally these special domain techniques are good, easy to implement, easy to understand. But the outcome or the output of the special domain technique, the fused images which we get from the special domain techniques are having the artifacts such as ringing or the blurring effect. When we move to the transform domain systems, transform domain techniques, the most important artifact is there is a blur at the edges. And even this transform domain techniques generally tries to give the inconsistencies in the fused image. And the learning domain techniques are good, they are still getting evolved. And that's the reason in the proposed methodology, we have proposed the fusion, or we can say the amalgamation of these three techniques. The three techniques are a principal component analysis, guided filter, and a convolutional neural network to get a resultant fusion image. Now, the proposed methodology mainly consists of the images, individual images, which are of the same object. Either they are differently focused or they are having the different illumination, and thus there is a need of fusion of all these images. So these are all I1, I2, I3 up to IN are the source images. As we all know, the histogram equalization, a very simple technique, but it gives the contrast enhancement in the image. This contrast is a visual ratio of a different tones in the images. These different tones or this different, when you have the contrast enhancement in the images, this is where we really give a difference in what we create, like in a texture, highlight, shadows, colors, clarity. So all these points of the images are getting enhanced or highlighted through the contrast enhancement. And the histogram equalization is the most simplest and the efficient method among the all to improve the contrast in the image. So generally what we do in the histogram equalization is just we spread out the most frequency intensities values. That means that we stretch out the intensity range of the image, and this gives us the global enhancement in the contrast. So with this histogram equalization, we have the principal component analysis, guided filters, and convolutional neural network also. So we will see these all components one by one ahead through this proposed methodology. So the same, this proposed methodology is elaborated with the input images and output. Here we can see that how the input images are there. So these input images, we can see that there is a difference in the illumination in these input images. And at the end, when we go with the output image, there we get a all-in-one image, which is having the a good illumination effect with the output. And these are the different components and how they are getting utilized in the proposed methodology. So let's see one by one. So here I have shown that how the histogram equalization works. This is all the intensities are getting equalized. Then in a PCA module, generally this PCA and a guided filter module are used to fetch out the weight maps from the images. Now the principal component itself always says that this is where we would like to fetch the principal components and get rid of the redundant components or unimportant components from the images. So this is how we will be getting the most focus or most identified area or most focus area of the images through the weight map of the principal component, or the PCA output gives us the weight map which is having the more focused pixels. Now this guided filter is generally having the strength of retaining edges of the image. So with the help of the generation of the guidance image from the given input images, we will like to retain the edge information of the input images. And then comes the CNN module. Now this is a pre-trained module, which is already available in a MATLAB. So we have used the VGG29 CNN module, which helps in the fetching of the highly illuminated pixels of the images. So when we have the problem of the ill illumination in the different input sources, from some of the sources, some sources having some pixels as a good illumination, other sources have the some pixels as a ill illumination. So only the good illuminated pixels are captured, or those chromaticity values are picked by this CNN pre-trained CNN module, and which is again saved in the feature vector, or we can say a weight map. So here we can see that we combine the weight map of the CNN and guided filter. Already this guided filter weight map is combined with the PCA module. So all these weight maps are combined with the average weights and then converted to the final weight map. Now this final weight map is applied on the individual on these images to get a final fused image to the guided filter. The histogram equalization helps in the contrast enhancement. So generally at the start of all these processes, we apply the histogram equalization. Now we can see through the images on the screen that if we have an input image through the histogram equalization, a B image is another image where we get a enhanced image. The histogram equalization is used to enhance the contrast, and even the entropy is also improvised in the histogram equalization. So the first table tells about the original image entropy and the entropy after the histogram equalization, and the second table depicts about the original image contrast and the contrast after the histogram equalization. So we can see for this given three samples, the histogram equalization after the histogram equalization, the entropy as well as the contrast has been increased. Now, after the step of histogram equalization, the proposed methodology of PCA guided filter and CNN is applied to get the weight map, a revised weight map, which is consists of the most illuminated pixels of the given image, and then to get the output fused image. Now, from the output which is shown on the screen, we can see that the input images, which are differently focused, which are already and then these images are gone through the histogram equalization, and then the fusion technique is applied with the PCA, GF and CNN, and to get the output resultant fuse image, which is shown as E. So we can see that there is an improvement in the contrast in a resultant images, and this resultant images is good in a contrast, as well as the resultant image having the all area as a equally focused area. So left focus, right focus, few individual images were there. That problem is solved in the resultant fused image, output image. After the histogram equalization, and so this particular experimentation is performed on the medical images as well as the sample multifocus images, and we can see that the entropy values which we have received in a fused image are as shown in the table, so which are as good as a higher range, because they are all the entropy values are above 7. And thus the given proposed methodology is compared with the existing methodologies also, which are there in from the literature. And when it has applied with the same data set, the 8 images of the same data set, means 4 images of a multimodal and 4 images of a multifocus data set, we can see that the proposed methodology is having higher values of entropy as compared to the existing methodology. So this is how the proposed we can prove that the proposed methodology is better in a working, and this betterness in the working is due to the first histogram equalization method, which is followed by the amalgamation of PCA guided filter and CNN module to generate a weight map, which is applied on the source images to get the resultant output images. So the contribution and the conclusion part is this process is important. This process is used to enhance the entropy value. The principal component analysis is used to get only the important or the principal components of the image and to get rid of the noise or the redundant information from the image. Now this guided filter is used to preserve the ages information, and then the technique of histogram is used to enhance the contrast of the image. Later on, we used this CNN to get the more intensified pixels from, or to generate a more intensified weight map of the pixels from the given input images. And this amalgamation is used to preserve the features, get rid of the noise or the redundant data, and to improve the contrast of the input images. And this is how the proposed methodology is contributing to the field of the research. Thank you all. Is there any question?
It was very much great and detailed presentation, Nalini ma'am. So I would just like to know that whenever we are doing image fusion, at that time, if there is any at the background, if there is noise, then how it is handled very first? And second question would be that is how it is different and better than other the fusion techniques, like suppose wavelet transform or other techniques, how it is different than this, and how much quality of the image it is going to improve?
Yes, ma'am. So the first question is about the noise. Now the noise is a redundant data, or now noise is a outliers. It is other than the existing. It is something very much different than the regular data or the regular intensity of the given pixels. Now the principal component analysis just try to collect the principal components only. If the noise is like a outlier, so they are very less in amount but high in intensity. So if you consider about a pepper noise, salt and pepper noise, or the Gaussian noise, so they have a different value. So generally the principal component analysis tries to remove this noise from the data, because itself as we know the procedure of PCA, that it generates it takes the help of the covariance matrix to generate the eigenvalues and eigenvector, and this eigenvector consists of the important data features, and that is where we have removed the noise from the data. The second part is this particular proposed method is different. How it is different than the existing methods? Because it is the amalgamation or the combination of the methods which are already there in use. But this individual methods which are there, they are having some of the lacunas. Now what we do is we try to correct the principal components from the PCA. Then we try to collect the high intensity pixels from the CNN, because the CNN is already a pre-trained network which is trained with the very high and good quality images which is pre-available with us. So with the help of these two techniques, we merge the weight map which we get from these two techniques, and thus it gives the advantage of having the good quality weight map, which generally helps us to get the good fused result. And when we come to the other domain techniques like a transform domain techniques, now this transform domain techniques is as they are good, they are a bit complex, and the most important disadvantage of the transform domain technique is blurring at the edges. And now this blurring at the edges, we want to remove this particular disadvantage of a transform techniques. And that's the reason we have moved to the guided filter, where the guided filter is helped in the decomposition of the image. So it decomposes in the base and detail part, where the detail part is generally consists of the high information. And the next important part is the guided filter is also need a guidance image. And now this guidance image is generated from the given input images only. So the edges, guidance images generally are one which is having the edges. Now these edges are preserved in the guidance image. And at the last stage, when we try to fuse all these, we try to fuse all the input images with the help of the weight maps, which are generated from CNN, PC, and GF. We take the help of this guidance image also to retain the edges from the input images. And thus that particular, the disadvantage of blurring of the edges is completely nil in the case of the proposed methodology. So this is how the proposed methodology helps in improvising the quality of the image. And then from the table also we can see that almost we get all the existing methods. The same technique is available. With the same data set, we have applied the techniques which are available in the literature. And so we have got the values in the range up to 7. But there is an improvement in the proposed methodology by say 0.0, 0.10, 0.20 in that range. But at least there is an improvement by say 10% to 20% in the proposed methodology in the case of the entropy. So this is how the this computationally also, or the objectively also, we have enhanced in the proposed methodology. I hope
yes, it was. Yeah. So that's it from my side. Any questions, audience? Okay.
Thank you, ma'am. Thank you, audience.
Thank you for your great presentation. And now we are moving further to our next presenter. And I would like to invite Monica Arya to present her paper on the title Machine Learning Based Autonomous Framework for Product Classification or Cloud. Dear presenter, you can now please start the presentation.
Hello, am I audible?
Yes, you are audible. Please go ahead.
A very good afternoon to one and all present here. And I am Monica Arya. I will be presenting the paper on the topic Machine Learning Based Autonomous Framework for Product Classification over Cloud. And the authors for this paper are Dr. Anand Mantwani, Goldi Bajaj, myself, Monica Arya, Dr. Sumit Sar, Dr. S. Oswald Manoj. This is the table of contents for my presentation. We'll start with the background, then proceed with the roadmap of the research. I'll then discuss the novelty and the contribution of this paper. We'll go then through the literature review, proposed work, the experimental setup, materials and method used for this paper, then results and discussion. And finally, we will discuss the conclusion and the future scope. Now to just review the background, the progress towards the e-commerce on the internet has shaped the business policies like the e-wallets that seemed impractical earlier. Now we are highly relying on the e-commerce, and the e-wallets are getting more popular nowadays. So EC has permitted the business to offer more choices to the consumers. EC companies are maintaining the extensive database of the products, customers, their transactions, and the purchase patterns. The purchase patterns, what we are using, it is being followed. And obviously, whenever we open our Facebook, we open our Instagram, we get the suggestions to buy certain products based upon the patterns. And however, the product classification on the basis of attribute is a cumbersome task. Now, it is essential to efficiently categorize the product in order to measure the interaction with different product categories on an e-commerce platform. This is a very challenging task. Therefore, it needs an automated framework which is based on machine learning. So applying the popular machine learning algorithm to the large-scale data set, it has brought a new comforts to the ML practitioners. The traditional ML repository, it cannot handle the processing on a large data and scaling. So cloud computing paradigm, it has become a valuable option for accelerating the ML platform and solving the issues of big data handling and computation with minimal effort. So here in this proposed work, we are clubbing the cloud computing paradigm with the machine learning platform to harness the advantages of cloud computing. This is the roadmap of the research. So the present work, it will discuss on the data mining, the ML, and the significance of predictive analytics based on ML in the e-commerce domain. The review of, in this paper, we will also review the multi-class classification and various mathematical model. Then the survey of e-commerce and relevant classification framework is also carried out. And finally, in this paper, the autonomous framework for product classification, it is proposed and it is implemented over the Microsoft Azure Cloud platform. Now, what is the novelty and the contribution we have made through this paper? So the first contribution is the proposed work is an autonomous framework for product classification. It is implemented over the scalable cloud platform, Microsoft Azure. The work predicts the category of product in the huge product data set released by a well-known e-commerce company to compete. And the optimized multi-class logistic regression, that is OMLR, by selecting the relevant feature and tuning the hyperparameters. It is deployed over a leading ML workspace over a cloud Microsoft Azure platform. And the outcomes of the proposed framework are they are compared and they are assessed in terms of accuracy. Literature survey, the most relevant and the recent literature which maps to the paper, they have been studied, and the framework they have used, it was studied, and what application domain they are using that framework, that was also chalked out. So in the first paper, we have seen that an automatic product categorization mechanism, it was proposed, and the application domain was e-commerce. So in the second paper, naive-based KNN, SVM along with LDA was proposed, and the domain was same, the e-commerce. So for e-commerce, we have used the multiple papers like multiple classifier, including BaseNet, then classification over random forest also, and multi-class classification using open source H2O machine. It was used for letter recognition data. So we have studied the domain, application domain of various domain like e-commerce, the letter recognition data, the medical image also, and the credit card telescope data also we have studied in the literature. Now the proposed work. So the proposed framework, the input data set is first pre-processed, and it is converted into the most suitable format to give the more accurate result. This is a very initial step which is needed in ML, as the quality of the data, it suggests the performance of any ML algorithm. So the most suitable ML algorithm are iteratively applied to the next step, and the candidate model is determined. So in the framework proposed, the hyperparameter tuning is also applied to the model for the better predictive accuracy. And finally, the cross-validation is used to validate the constructed classifier. And finally, we have came to the conclusion that it also improves the classification accuracy by retraining or tuning the model parameters. So the model is fine-tuned, deployed, and finally evaluated. It is based on the final test set. The OMLR learning algorithm, it is trained, the model is used to train the model. To tune the model algorithm, hyperparameters are adjusted. And finally, the original and the proposed classifiers are scored and compared with each other to evaluate the proposed classifier. This is the proposed framework. As we can see, the input data set, it is first pre-processed, and the data set is prepared. Then the ML models are applied, and the appropriate candidate models, they are selected, and they are optimized and fine-tuned. Finally, it is deployed, and it is applied in the e-commerce data. And this all, it is deployed in the Microsoft Azure ML workspace. Now the experimental setup. For the experimental setup, the Microsoft Azure ML workspace is used, and the MAML workspace, it includes the ML Studio, ML Gallery, ML Web Service Management also. So from start to the finish, the Azure ML Studio is a graphical platform for implementing the KDD process and methods. So it includes various data processing modules, a set of ML techniques, and API to access the model deployed on the cloud. The materials and methods. First, we'll discuss about the dataset. It is provided by the Auto Group, which is a large e-commerce company. This dataset, it includes 61,878 instances, and each row represents a single product containing one or more of the 93 features provided in the datasets. So the features are entirely obfuscated. This means behind the 93 features and what the 9 categories are remains unknown. The randomly selected products are to be classified into 9 categories. So finally, there are 9 classes in which the products are to be categorized. The approaches, machine learning approaches we have used here is binary classification model, then regression analysis, and third one is a multi-class classification model. So this is a snapshot of the model which was implemented in the MAML platform. So it shows the roadmap, or it shows the flowchart of how the product data was captured from the .csv file. Then we split the data into the training and the testing data. Then how the data is summarized. It was applied in multi-class logistic regression, and the hyperparameters are tuned, and the score model is finally evaluated with the other existing models. The results and the discussions. So the evaluated results are derived from the confusion matrix. So it is a real-time snapshot of the testing outcome that is in the next slide. So the confusion matrix, it is also known as the error matrix. So it is a matrix to describe the classifier's performance. So this is the real-time confusion matrix which is captured. And the performance is evaluated on the base of accuracy. So accuracy is basically the quantity of correctly classified examples, and it is divided by the total number of examples. And this table, it shows the accuracy percentage of the existing LR-based classifier and the proposed cloud-based classifier. And the class product categories, we have evaluated the accuracy for each category of the product. So there are 9 categories of the product, and how our proposed algorithm is performing with each of the category, it is summarized in the table. So based on this table, we have developed the graph which compares the accuracy of the proposed model with the existing LR-based classifier based on each class. So here, looking at this table, we can see, or we can compare that the proposed model, which is cloud-based model, it is performing better than the existing LR-based classifier in mostly all the 9 categories. Now, conclusion and the future scope for this work is that the model, it is used an optimized MLR algorithm to train the classifier, and the evaluation results demonstrate the higher performance than other classifiers. So the performance of the cloud-based classifier framework enhances the overall categorical accuracy independent of computational resource limitations. So here we are not considering any resource limitations, and we are seeing that the cloud-based classifier, it is performing well in all the categories. The proposed research, it may provide a possible approach for building the model to address a multi-class classification problems in big data, which is a great challenging task nowadays, because every data, it is converted to big data. So in future, the model can be modified for applications on Hadoop and MapReduce platforms. The proposed model, it can involve in cloud-based web services, and it can play a significant role in data analytics. That's all from my side. Thank you.
It was a nice presentation. I would like to know, have you done any feature selection before building the model?
Yes, ma'am. Features were selected. Features were selected adaptively, like the new features which are coming. They are also included. So every time a new feature comes, the model it again undergoes the feature selection process, and a new subset of features, including the new features, they are selected, so that the problem of concept drift it is taken care by selecting the new features.
Which is the classifier used for multi-class?
Ma'am, MLR.
Miss, what is the reason to select only this model? Why not the other models?
Because, ma'am, when we have deployed it with the cloud platform, this model, we have tried with other models also, but respective to time taking for the computation and other parameters, we have found that the MLR, it was performing better than other ones.
Have you used any cloud microservices?
Microsoft Azure services, ma'am, we have used here, but we have used the free services. But obviously, if you want to extend the work, we will go for some paid services also, and we can improve the model.
Okay, that's it from my side.
Okay.
Any questions, audience? Okay, so I think we can go for the next presentation.
Thank you, ma'am.
Thank you for the presentation. And now we will move further to our next paper. And I would like to invite Pooja L to present her paper on the title, Privacy Preserved Effective Bill Collection System Using Blockchain. So dear presenter, you may start the presentation.
Yeah, thank you. So can you see my screen, right?
Yes.
So good evening, everyone. Yeah, good evening, everyone. This is Pooja L, who is studying MTech program in the Bangalore Institute of Technology. So I would like to present my paper today. Hello.
Okay, so I think Pooja maybe having some technical issues. So we will move further to our next presenter. And I would like to invite our Adeline Frida to present her paper on the title, Test Suit Minimization for Regression Testing Using Keyword Match Technique. So dear presenter, you can now start the presentation.
Can you hear me, ma'am? Ma'am, can you hear me?
Yes, you are audible.
Okay, thank you, ma'am. Okay, so I'm our admin Frida. I'm happy to present in this conference. So my topic is test suite minimization for quality test using clustering and prioritization techniques. And I'm doing my research at Hindustan University. My guide is Dr. P. Selvi Rajendran. This is the flow of my review. The research context is which I'm going to discuss it is test suite minimization, test case selection, and prioritization. Okay, able to move. Okay, so the background of this this particular work. So when an application is being developed, a huge number of test cases have to be tested in order to produce a quality software. So in order to, which involves lot of manpower and cost factors are involved in it. So we are moving on to regression testing, wherein where only the recent changes are being tested. And so for that, we have to select the particular test cases that are going to be test the changes that are being implemented in the system. Okay, so that is about regression testing. And this regression testing can be done using three techniques. That is, retest the entire system as such. And the second one is we are selecting only the portion where the changes are being implemented. That is a test case selection for that particular place where the changes are being implemented. And then prioritizing of test cases. So the test cases which are being of most important, they are being prioritized, and the test cases are being ordered based on their priority. So these are the three regression test techniques. And I have told you about this test suit reduction, test case selection, and prioritization. So now this shows a pictorial representation of the test suite. So initially, before the system is going to be tested, a test plan will be generated. So the test plan will have the various number of test suites that is going to be implemented on the system under test. The test suite will have a n number of test cases. Now we have in these test cases, each test suite will have thousands of test cases, and here every time when we use the 1,000 number of test cases in a particular system, the time and the cost involved is more. So in order to minimize that, we are moving on to regression testing. So the test case prioritization, the schedule test cases for execution in an order that attempts to increase the effectiveness at meeting some performance goal. So one goal is the rate of fault detection. So how early the fault is detected, the measure of how quickly the faults are detected within the testing process. And an improved rate of fault detection during testing can provide a faster feedback on the system under test. So here we are prioritizing the test cases like in order to how earlier it identify the defect that is being present in the system. So this is the literature review that I have done. For initially, I have done a number of around 6 to 7 papers as a review, and the first paper has been 2020 paper. The machine learning technique is being implemented for reducing the test suite that combines k-means clustering with binary search. And like that, then again, the research on k-value selection method of k-means clustering algorithm, which was implemented in the year 2019. The choice of k-value.
Hello, Adeline. Sorry for the interruption, but can you please present your presentation again? Because our session share is not able to see your presentation.
Oh, okay.
Just try to share it again.
Okay.
Yes, I can see now. You can start from this slide.
Okay. So can you see my this slide, ma'am?
Yes, I can.
Okay. So yes, these are the n number of papers that I have reviewed. Then the test cases have clustered using k-means and an evolutionary algorithm, which is a multi-objective optimization algorithm. The objective includes maximum fault detection rate, the statement coverage, the maximum number of statements that are covered, and minimum execution time. And finally, the last paper is multi-objective test suite optimization for detection and localization of software faults. The test suite minimization, the method implemented is that the test suite minimization through maximizing and the statement coverage, branch coverage, and diversity aware mutation adequacy criterion. So all these papers show that the test suite can be minimized using various techniques, and the research gap which I have identified is that the gap in the test case prioritization for multi-objective test suite optimization, including cost, fault detection, code coverage, and evaluation metrics. The models and frameworks like JUnit, Selenium, so all these mechanisms are not providing any mechanism for prioritization of test cases. So these models or frameworks which already exist, they test the entire suite or they test the entire application when a change is being done. But it is a mere waste of time and cost when only a portion of the software is being changed. So that is why we are moving on to this technique. So I have implemented a keyword match technique in order to do this test suite minimization. And for the data set I have used e-commerce test cases which has been developed for an e-commerce website. And for this algorithm, I will show the initially the requirements are being segregated as functional and non-functional requirements, and each requirements are being given weightage. Say the weightage of 3 for functional requirements and 2 for non-functional keywords. Now these requirements are being segregated and it is being put under 2 sets, and let there be the test cases under this TC set and the number of modules under M. Now initially the requirements are extracted from the problem statement, and a master keyword table is being generated. So for each of the keyword that is under the functional and non-functional requirements, a weightage is being assigned, and finally the total weightage is also being calculated. And how the match percentage is being, we will see how the match percentage is being calculated here. Fetch the weight of the keyword if the string matches the master keyword table. So there will a match technique. We are following a match technique, and if the match is found for in a particular test case, how many keywords are being matched? So according to that, the total match percentage is being calculated, and then it is being jotted down into an RI into TC mapping table. So this is the flow chart which gives you the glimpse of the the flow chart, which the algorithm which I had given there. So this is the key table that is being generated after the algorithm is being implemented. So here, see, there are for a particular module, there are n number of requirements and the n number of test cases. So here, for the particular requirement 1, test case 5 is having the maximum coverage. So the test case 5 is being prioritized. So like that, we can prioritize the test cases so such that in order to reduce the time and cost that has been involved for doing this regression testing. So finally, as a conclusion, to achieve best suit minimization with the maximum test coverage for regression testing and the effective test case selection that yields maximum statement coverage to reduce the cost and time involved in performing regression testing. And this is the reference that I have used. Thank you.
It was nice presentation. I would just like to know that, is there any limitations of the system?
Ma'am, I've just implemented this algorithm on my own. There are many machine learning algorithms, keyword pattern matching algorithms are there, but I did not use those algorithms. So such that I have framed an algorithm that best suits my system. So I have never gone through the drawbacks of the system.
Okay, so is there any assumptions that you need to make that this should be like few assumptions should be there in your system? So what are that?
So for the I'm assuming that I'm segregating into functional and non-functional requirements, and for that functional requirements I'm assuming some weightage, and for non-functional requirements I'm assuming some weightage, and based on that assumption only I am calculating the approximate weightage and prioritizing the test case.
Okay, nice presentation. That's it from my side. Audience, any questions?
Okay, so now I think we have completed all our presentations. And I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 6th version of the conference. We will be happy to have you in the 8th version in 2023. So all the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to Springer. And the publication will be live within 6 months. So kindly cooperate with the team of ICTCS 2022. And I would also like to thank our session chair, Professor Gitanjali Shinde, for chairing the session. And here is a small token of appreciation on behalf of the team ICTCS and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Thank you, Anisha, for the nice coordination. And thank you, ICTCS, the team, for inviting me and giving opportunity to discuss with the young minds and on this lot many different various topics. So thank you very much.
Thank you, ma'am. And now that we have come to an end of the session, I would request you all to please switch on your cameras for a quick snapshot of this virtual conference.
Sorry, actually, I'm working from desktop, so.
Okay, no issues. Okay, thank you so much, everyone. Stay safe and take care.
Thank you. Bye-bye.
Thank you, everybody.